Hi, grade 12 student. Our study today about the intermediate value theorem for continuous function. What does this mean? If you have a function which is continuous without interrupt, starting where domain is AB and codomain is f of A and f of B. So since we don't have interrupt, if you pick any point between f of A and f of B, and if you draw horizontal line, so this horizontal line 100% should cut the curve AB in at least one point C between A and B. You have, in this example, because it's continuous from A till B, so if you pick any point between f of A and f of B, here you have more than one point of intersection. You have C1, you have C2, you have C3. If you draw here, you have only one point, for example, you projected between A and B. Let us take example to understand. You have a continuous function y equal f of x. It has a negative value at x equal to 0 and a positive value at x equal to 1. You know, you want to prove that f of x equal to 0 has at least one solution between 0 and 1. Let us graph the picture first. F of 0, we said it's negative. Let this negative value be a. Here 0. Suppose this is a. And f of b, f of 1 equal to b, where b is positive. So this is 1, this is 0. And suppose b here is a positive number. Since the function is continuous, you must pass, you go from this point till that point, but continuous, no interrupt. As you can see, you look first of all at the y-axis. You have from A till B. Because I want equal to 0 in y equal to 0, 0 in this one is between A and B. By the intermediate value theorem, going from minus to positive, this curve should cut the x-axis in at least one point C. And this C must be between 0 and 1, which is correct. Why? By the intermediate value theorem. So I'm going to repeat, 0 is between A and B because A is negative, B positive. By the intermediate value theorem, you must have at least a point C on the curve such that f of C equal to 0 and C is between 0 and 1. Another example. Here you want to prove that this equation, this function which is continuous, has a root equal to 0 between 1 and 2. So we do first of all f of 1. What is f of 1? F of 1 is minus 1. So if you have 1, you have minus 1. And if you do f of 2, you have 5. Suppose this is 5 here. So because the function is continuous, you go from here till here. But while going, you must cut the x-axis in a point what C, such that here f of C is 0. By the intermediate value theorem, this is correct. Why? Because first of all, 0 is a point between 1 and 5 here. Okay, which is here. So there exists a point C between 1 and 2 by intermediate value theorem because the function is continuous such that f of C is 0. So here if you replace this C, you're going to get C cubed minus C minus 1 equal to 0. We have a solution. Another example. Here if you have something equal, function equal to function, has a solution, I want you to bring it to the first side. So it will be plus x squared minus 4. So what do we need to show? You want to show that this is equal to what? If you bring it to that side, it must be 0. So we're going to compare to 0. Let us pick any point randomly. The first one be 0, the easiest one. You're going to get radical 5 minus 4. Radical 5 minus 4 equal minus 1.76, which is negative. If you take f of 1, it's still f of 1 negative. So let us take f of 2. So for f of 2, it will be radical 9, which is 3 positive. So you have here at 0, we have minus 1.76. At 2, we have 3. So this is 0, this is 2, don't forget. So going from here, because the function is continuous, by the intermediate value theorem, because here I have a negative value, which is minus 1.76, here I have a 3. 0 is between these 2 points, between minus 1.76 and the 3. So by the intermediate value theorem, this curve must cut the x-axis in a point C where f of c is 0. And c is between what and what? C is between 0 and 2. So we have solution. So here, if you replace c, what do you get? Radical 2c plus 5 plus x squared minus 4 is 0. Take c squared minus 4 to the other side. So I'm going to get this one with the point C, which is a solution of that equation. Another example, cosine x equal to x. You can take it to the first side. Let us start by f of 0. Cosine 0 is 1 minus 0 is 1 positive. F of pi over 2 cosine 90. You all know 0 minus pi over 2 is negative. Similarly, going from positive to negative, 0 is between these two values, between 1 and pi over 2. 0 is between minus pi over 2. Here you have minus pi over 2, and here you have 1. So 0 between these two values. By the intermediate value theorem, because going from minus pi over 2, suppose this is minus pi over 2. Sorry, you have minus, sorry, let me repeat. F of 0 is 1, so if this is 1, the first point. If you have pi over 2, suppose this is pi over 2, 3.14 over 2. You have the image is minus pi over 2. So going from positive to negative, by the intermediate value theorem, this curve must cut the x-axis in a point C such that f of c is 0 and c is between 0 and pi over 2. Another example, here we have variable a plus b over 2, and we have value for which we have a solution here, and the point x is a plus b over 2. So here we don't have numbers, we're going to start by a or b. Suppose a less than b. If you take f of a, here will be 0. 0 times any variable a minus b squared is 0 plus a. If you replace by b here, this will be 0 times b minus a, 0 remains b. So you have f of a is a and f of b is b. We all know. So here what do you have? You have 2 points, a and b. A is smaller than b. So f of a equal to a, f of b is b, and a is less than b. So you have this case. Okay? Here you have f of a, here you have f of b. We all know that a plus b over 2 is between a and b, between these 2 points, because this is the average of a and b. So by the intermediate value theorem, if you draw a horizontal line, we have a solution, and this solution must be between a and b, c. Another example, show that we have at least 3 solutions between minus 4 and 4, and this is a continuous function. We start by taking minus 4, we replace it, minus 3, minus 3, minus 2. I'm taking all the integer. So I want 0. So to find the solution by the intermediate value, you must have a minus then plus. So here you have a 0 here between these two. So I have a C1 between minus 4 and minus 3 by intermediate value theorem. Here I have positive negative, so 0 exists in the y here. So I have another C2 between 0 and 1 by the intermediate value theorem. Here I have 0 between minus 17 and 5. So I have another C3. So by the intermediate value theorem, I have 3 points, one between minus 4 and minus 300%, another point between 0 and 1, another point between 3 and 4, such that this equation equal to 0. I want you to do that homework. You have number 1, number 2, number 3. You can take a picture, you solve it on a piece of paper. Then you check the solution. This is solution of the first problem, number 1. You can take a picture to check. And this is a solution for number 2 and 3. Hope that you have enjoyed the intermediate value theorem, and see you tomorrow in class.